This is for Year 12 Methods. It's 2016 Exam 1, question number 5. So, f has a restricted domain, so it's a logarithm. G has all real numbers and it's a parabola. So the domain of f is 0 to infinity, and the range of f, well, f looks like that. So the range of f is all real numbers. The domain of G is all real numbers, and it's a parabola that's been moved up 1 unit. So the range of G is 1 to infinity. Find the rule for H, where H is G inside of F. G inside of F. So does the range of G fit inside the domain of F? Yes, it does. So G goes inside of F. So F of G of X is equal to log base E of x squared plus 1. State the domain, or the domain of f of G of X equals the domain of G, which is 1 to infinity. And what will be the range of H? Well, if I put in 1, I'm going to get log base E of 2. When I put in a bigger number, it's going to be, say, if I put in 2, I get log base E of 5. So when I put in 1, I get log base E of 2. When I put in 2, I get log base E of 5. So my range is going to be, my lowest is going to be log base E of 2, and I'm going to go to infinity. Show that h of x plus h of minus x equals f of G of x all squared. Okay, so h of x is this. H of minus x is minus x wherever x is. So it's the same as 2 log base E of x squared plus 1, because negative 1 squared is x squared, which is the same as log base E of x squared plus 1 squared, which is the same as the squares on the inside, so it's the same as log base E of G of x all squared, which is the right hand side. Find the coordinates, the stationary points of h. So I need to take the derivative of h. So d dx of log base E of x squared plus 1 is going to equal 1 on x squared plus 1 times the derivative of the inside, which is 2x. So 2x on top of x squared plus 1. Stationary points is when it equals 0. I can ignore the bottom, so that will only be 0 when x equals 0. So the coordinates will be 0 and 0 plus 1 log base E of 1 is 0, and 0 is going to be the stationary point. What will be the type of stationary point? I need to do a sign. So here is my sign diagram. I know that the derivative equals 0 is 0. So if x equaled negative 1, I'm going to have negative, and that's going to be positive, so it's going to be negative. And at positive 1, the top's going to be positive and the bottom's going to be positive, so it's going to look like that. So a local minimum at 0, 0. And lastly, let k have the domain where it's equal to k of log base E of x squared plus 1. Find the inverse rule. So x is going to equal log base E of y squared plus 1. E to the x is going to equal y squared plus 1. Y squared will equal e to the x minus 1. Y will equal the plus or minus square root of e to the x minus 1. Since the domain of this was negative up to 0, then the inverse k negative 1 of x is going to equal the negative square root of e to the x minus 1, because its range has to be negative because the domain of the original was negative. State the domain and range of the inverse. Well, it's going to, so the domain of the inverse will equal the range of k, which will be, when that's 0, that's going to be, when x is 0, that's going to be like we said, 0 through to infinity. And the range of k inverse is going to equal the domain of k, which is negative infinity to 0. And that's the question.